Of course, in today's video, I'm actually going to talk about comparing two meals, okay, for independent samples. Okay, so on the outline, I'm actually going to walk you through hypothesis testing for difference between two population means. I'm also going to walk us through how to construct the confidence interval for the difference between two population means. Of course, I'm actually gonna back that up with illustrative examples. Okay, so let's get started. We got two populations, we got two groups, and we actually want to compare uh, means. Of course, we find ourselves in a world we're never going to have you know there's going to be variations, of course, and that we call for effective comparison. Okay, so you may want to compare, um, you know, the average household income in two countries. Maybe you want to compare the average household income in United States and Canada. Of course, we actually need to take a random sample from the two population. And what we want to do is to compare two unknown means corresponding to two independent samples. Okay, so this is a population one. So in population one, we actually gonna have you know, population mean. In population two, there's gonna be population mean, and of course, we do not have enough resources to study everybody in the population. Of course, what we normally do is to take a sample. But before taking sample, when we have a population mean, we're also going to have a population standard deviation. Okay, so they are knowns. Okay, so because we do not have enough resources to study everyone in the two populations, we actually going to take a sample size. So we're going to take a sample size N1 from population one and sample size N2 from population two. And based on the sample size, we actually gonna compute the sample means, okay, the X bar one is the sample mean from population one, and the X bar two is the sample mean for the population two. And of course, we're also going to figure out the sample standard deviation. So these are the numerical statistics that we're actually gonna get, okay? Actually, we're gonna have an assumption, okay? We can have an assumption on whether the population standard deviations are equal, and at times we could relax that assumption, but we're going to let you know. Okay, so if I want to look at the difference between two population, okay, I can actually, of course, when I take a sample size N1 and take a sample size N2, I'm actually going to get the mean of the population one, the mean from the sample, the sample chosen from the first population. I'm also going to get the mean from the sample taken from the second population. Okay, so that we can actually say, we can use this guy to represent the estimate of the difference of population mean. So because this guy is going to give us a single value, we're actually going to call that a point estimate. Of course, in this class, actually said, if sample mean varies across individual, we expect that whatever algebraic operation performed between two sample mean, will also vary. Right now, we're subtracting that, right? That's actually going to vary. Okay, so because this guy is going to vary from sample to sample, and of course, we can actually impose the idea of a normal distribution on that. I want to say the moment the sample is large, or the population we're choosing from, which follow normal distribution, we can authoritatively say, okay, the x bar 1 minus x bar 2 will follow normal distribution with a mean of mu1 minus mu2, and this is actually going to be the standard deviation of the difference that we call the standard error. I just wanted to take note of that. But at times, in situation whereby the population standard deviation are unknown, we're going to replace sigma 1 squared by S1 squared, which is the sample variance. We're going to do the same thing. We're actually going to repeat the same thing for sigma 2 squared. Okay, so the standard error is going to be that instead of this guy here. We normally use this as a standard error for the difference of means, or if the two population variances or population standard deviation are given. But situation where they're not given, then the sample variances will replace them. Just wanted to take note of that. Okay, so I want to walk you to confidence interval for difference of means. Why do we need confidence interval? Because when you go back to the point estimate, this particular formula could give a result that could be too high or too low. Okay, that's not reliable, right? Okay, and because of that, we actually need to construct an interval in such a way that the true the the true difference of the population mean we actually lie. Okay, I want to welcome you to confidence interval for difference of means. Of course, we're gonna start with the assumption if you want to do that. Number one assumption is that the two independent samples have to be random. And of course, each distribution that we're going to choose the sample from has to be normal, or we're choosing the last sample. And how large is a large? How large is a large is that the each sample size that we're going to choose from each of the population has to be at least 30. Just wanted to take note of that. So what is now going to be the formula right now? The formula for confidence interval actually going to be this guy. If you take a look at this guy, it's going to be a point estimate of the difference. And we're going to see what happened after the plus or minus all of that. It's actually called the margin of error. Okay, the whole of this guy. That is the margin of error. And of course, the margin of error, I can split that into two, into the standard error of the difference and the t-score. Okay, this guy is a t-score. Okay, the t sub squared alpha over 2, comma degree of freedom. Okay, and before you can get a t-score, you need to be able to figure out what your degree of freedom is and what is your level of significance. Of course, I know when you are asked to construct a confidence interval, they're going to give you the level of confidence. The moment you have the level of confidence, you're actually going to figure out the level of significance. And what about the degree of freedom? You know, um, when you take a sample size N1, okay, you're going to do L subtract 1. When you take a sample size N2, you're going to subtract 1. Then the degree of freedom is going to be the smaller of the two. Because I'm going to say this, there's possibility the sample size that you choose from each population may not be the same. Okay, the degree of freedom is always going to be the smaller value. I just wanted to take note of that. Okay, now that is how to go about I put the confidence interval for difference of means. Before I walk you through example on this, I'll quickly walk you through the hypothesis testing for difference of means. I want to welcome you to the hypothesis testing for difference of means. Okay, what are the procedure? Don't forget, whenever you want to conduct hypothesis testing, you actually got to go through the 5 procedure. Okay, the procedure number 1. When you take a look at the procedure number 1 right now, we're going to look at the assumptions. And of course, you actually going to have 2 assumptions. Number one, of course, is choosing random sample from the two population. And number two is either the populations are both approximately normal, or you're choosing a large sample. Okay, choosing a large sample, forget each has to be at least 30. And after that, you're going to go to the formulation of hypothesis. When you are formulating hypothesis, I told you the other time, the non-hypothesis is going to be quality sign. You're actually going to say mu1 equal to mu2. The alternative hypothesis, on the other hand, could be a less than, could be greater than, could be not equal. You're actually going to be the one that will figure it out. Okay, you're going to figure it out from the information given. Okay, the next is going to be test statistic. And of course, the test statistic is going to be a t-test. Okay, that's going to be a t-test. Okay, so and in the t-test, it is going to be equal to the difference of the sample mean divided by the standard error of the difference. So this guy is the standard error of the difference. And don't forget this, the degree of freedom is going to be the smaller of the two. Okay, so far so good. The next is actually going to be getting the p-value. Getting the p-value actually depends on the nature of the alternative hypothesis. Of course, if you're actually if your alternative is less than, of course, the p-value is going to be probability of a TDF less than T. If the hypothesis is actually greater than, okay, it's going to be that. And if it is not equal to, if it's a two-sided test, okay, it's actually going to be, the p-value is going to be 2 multiplied by that. Of course, I'm actually going to show you how to figure this out using our software. And of course, our conclusion remain the same. In the conclusion, you're actually going to compare the p-value with the level of significance given. When the p-value is less than the level of significance, or what you're going to do is to reject H naught. When the p-value is greater than the level of significance, you're going to fail to reject H naught. Okay, so those are the 5 procedure. I want to go into illustrative examples now. Okay, you got this example 10.5. The verbal SAT score were recorded for independent sample of students who intended, okay, who actually intend to major in engineering and students who intend to major in literature. Suppose histograms of both samples show no strong skewness and no outliers. What they're trying to say, no strong skewness is that the distributions for the distributions are actually likely going to be normally approximately normally distributed. And of course, you have the data given, the sample, the choose equal sample size from the two. They got a sample mean based on the sample size, and they got a sample standard deviation. And of course, what they're actually looking for is to compare if a significant difference exists between the true mean verbal score for intended engineering majors and the true mean verbal score for intended literature majors. Okay, so if you want to construct 90% confidence interval, take a look at this question now. They want you to construct 90% confidence interval for the difference of means. Okay, they really want to see, whether a difference is, okay, between the mean verbal score for students intended to major in engineering and students intended to major in literature. Okay, so what you're going to do, you're going to get a degree of freedom out. Of course, each sample size is 44, 44. If you subtract 1, that's going to be 43, 43. The minimum of the 43, 43 is going to be 43. I don't know what you're going to do now. You're going to make use of the formula for confidence interval of the difference of means. I'm actually going to start plugging in a sample mean, okay, that's what I plug in. You've already been given here, okay, you plug in that in, okay, plus or minus. Okay, I'm going to plug in the sample variance, the sample sizes, I've already done that. The next is we need, how do we get the t-score? Okay, how do we get a t-score? If you take a look at this guy now, okay, we're actually going to use a QT, okay, alpha over 2, okay, you can do 1 minus alpha over 2, okay, so 1 minus alpha over 2, okay, comma, then you're gonna your indicate your degree of freedom. Degree of freedom here now is 43, right? Okay, so for 90% confidence, your alpha is gonna be 10%. Okay, which is 10%, it's actually 0.1, right? 0.1. So you're gonna plug in the values of alpha here. So alpha over 2, 1 minus that, degree of freedom equal to that, it's actually going to return 1.68. And the moment you have the t-score, okay, then you'll be able to obtain the margin of error. If you use this guy to multiply this guy, you're going to have 15.72. 15.72 is actually the margin of error. By the time you're going to subtract from that, you add to that, you're actually going to get this. This is the confidence interval that you have constructed now. Now the next is going to be interpretation. Okay, right now, we're going to say we are 90% confident that the true mean verbal score for intended engineering majors is between 71.58 and 103.02 less than. Why do we say less than? You can say we got negative, right? Okay, so less than the mean verbal score for intended literature major. And let me also say this, if you take a look at this interval, there's no zero in the interval. No zero in the interval actually means significant differences, okay? One is significantly lower than the other, that's what I mean. Okay, so that is how to construct the confidence interval. Okay, for that. Now the next is, can we also have a way to conduct hypothesis testing on this? And of course, this time around, they wanted to determine if there's a strong evidence at the 0.01 level that the true mean verbal score of intended engineering major is less than that of intended literature majors. Assumption, don't forget assumption is going to be independent random samples, and don't forget it's either the populations that you're choosing your sample from follow normal distribution, or you're choosing a large sample sizes. Okay, so if you take a look at the statement here, it said determine if there's a strong evidence at the 0.01 level that the true mean verbal score of intended engineering majors is less, and you need to pay attention to be less than, and that's why in the alternative we're gonna have a less than. Take a look at that. The null hypothesis is always going to be an equality sign. I just wanted to take notes of that. Okay, the next is the test statistic. Don't forget, the test statistic is where you're going to have the difference of the sample means. And of course, the standard error of the difference is what you actually going to get from this. Don't forget this, but this is standard error, right? The square root of that, okay? We've already, since it's the same question, we've already computed that. That's 9.33. At the end of the day, your test statistic value is negative 9.35. Now the next is to get a p-value. Now in getting the p-value, you're actually going to write pt, okay, in the parentheses, your test statistic value, okay, negative 9.35, then your degree of freedom equal 43. Okay, how do we automatically give you this guy? You do not necessarily need to worry about this guy. We're using p-value. I'm going to take a look at this p-value now. It's very, very small, right? We can compare the p-value with the level of significance given. Okay, the level of significance given is actually 0.01. So, and as you can see, the p-value given is extremely small, okay, compared to the level of significance. Now what we're going to do is to reject H naught. When we reject H naught, we're actually going to say we got strong enough evidence to conclude that the mean verbal score of intended engineering major is significantly less than that of intended literature major at that particular level of significance. Okay, so that's how to do that. How do we implement this in R? Okay, even though my TA is going to walk you through that, I'm actually going to show you how you can implement this in R. Okay, let's say you're given data set. Okay, if you want to have access to the data set, this is actually the link. And you have a data set, contain the data collected, from a recent survey of University of Minnesota student. Okay, we have the data collected over the years, the gender, the eye, the TV, the assembly, up to the year course. And of course, um, we actually want to focus on the amount spent by male and female on year course. We want to see whether there's a significant difference between the two. And that's why we said, along with the other questions, the student will ask about the amount of money spent on their latest year course. Okay, so the question actually asks you to construct and interpret a 95% confidence interval, okay, for the true difference in the mean amount of money men and women spend on haircuts. If you want to do that, the moment you have your data set in, the moment you imported your data set into our interface, you need to be able to write this code. This is for male here, here called gender equal to M. Don't forget when you're collecting the in the data, M actually in the gender, M represent for men and F represent for female. Okay, so I just wanted to take notes of that. Then we're also going to do the same thing to female here. Take a look at that. And of course, the code in R is actually going to be T dot test. So T dot test now, you're going to, your male here, the female here, and of course, the alternative. Okay, whenever they ask about 95% confidence interval is always going to be two dot sided. Two dot sided. Then the confidence level is going to be 0.95 for 95%. You know what? You're actually going to have a code or the output generated. Okay, it's actually, this is the output from R. R is going to generate a lot of output. This is the test statistic value. This is the degree of freedom. This is the p-value. And of course, what you have here is the lower bound and the upper bound. Okay. R is going to come with a lot of output. Okay. I just wanted to take notes of that. Okay. So this is the confidence interval. Okay. The lower bound and the upper bound. Okay, and we can also use the same code to conduct hypothesis testing, okay, for two-sided. Okay, for 5% level of significance is the same as 95% confidence. So you're actually going to make use of this p-value. Okay, what this p-value is telling me now that the p-value is less than 0.05, you're actually going to reject. It's a significant difference between the mean amount of money spent by men and women on air calls. Okay, I just want you all to take note of that. Just one second. Hello? Yeah, but you get it. Yeah, okay, no, cash, careful. Mama expecting. Okay, so I'm back now. So that is how we obtain that. Okay, now um this is like I said, if you actually want to conduct hypothesis testing this time around, or test at 0.05 level whether may students spend less, okay, because they say less, okay, you actually going to indicate T dot T test, T dot test, then alternative is going to be less because of the less. Okay, for 0.05 level of significance, okay, the confidence dot level is going to be 0.95. And of course, because you're talking about one-sided test, okay, when you take a look at the confidence interval, you're only going to have only one side, okay? It's going to be negative infinity. And of course, the p-value associated with this test is actually here. This is less than 0.05, and you're actually going to reject H naught. Take a look at that. Okay, I think I'm actually gonna stop here. Um, let me see. Okay, I'm gonna stop here. Make sure you all stay safe and have a lovely day. Bye for now, everyone.